Okay, good morning, everybody. That's what you have with electronics. You have to switch them on before they work. I have to tell you, quite honest, this is a session without code. So if you're expecting a lot of code, I could take it into another direction if you especially want to see code, but I probably won't. So it's about modeling. And it's about modeling the requirements, and it's about modeling the requirements in larger projects, in service-oriented projects. And there's a technique which we call smart use cases that allows you to do a lot of modeling of requirements very early on in your project and go from there. And what I'll try to do is explain to you how that works, what this technique actually comprises of, why it's different from doing traditional use cases, as a lot of you might have done in the past or still doing, and also how you can estimate this stuff. And the fun thing about this is that it's a really reliable estimate on the size of your project if you estimate into something we call smart use case points. So I'm trying to explain that all to you, and most of the pictures I have in my presentations, well, all of them actually, come from real life projects. I also opened up a modeling tool which is called Enterprise Architect. Then I can try to show you some of the models that we actually use in projects. And that's about the story for today. Let me introduce myself first. My name is Sander Hogendoorn. I work for a very large company which is called Capgemini. I think globally we employ about 110,000 people, which is quite a lot. I don't know them all. I know quite a few of them, but I don't know them all. And I have this peculiar function title, which is called Principal Technology Officer, which sort of means that I deal with innovation of software development in a lot of aspects of software development, including modeling, testing, software architecture, frameworks, model-driven development, design patterns, stuff like that. That's why I'm also the Global Agile Thought Leader at Capgemini. One of them, actually, there's a few of them. I've written a couple of books, but they're in Dutch, so you won't be able to read them. My next book will be about use cases and will be in English, by the way. If you want to know more about it, there's the websites that go for it. That's my own website. And the smartusecase.com website is actually a wiki that belongs to our Agile software development platform that we have. And a lot of the stuff on smart use cases is also on there. If you want to ask me some quick questions, best is to tweet me. There's my Twitter account name. My email address is on the back of the slides as well, so hopefully you will be able to find me. So, this is more or less what I will try to tell you. A bit about service orientation, why it's hard, but why a lot of companies, a lot of large companies, still go down that road to be able to, for instance, get rid of a lot of the systems in their IT landscapes, or prepare for shorter time to markets, or try to get to a reuse of their software and even of their requirements. So there's a lot of arguments to go for that. And then I'll dive into the smart use case stuff. I try to explain to you what they are, why we use them, how to model them, how to identify them from the business processes in your projects, also how to write them down, and even a bit on how to test them. That wasn't in the title, but the title was too long already, so I couldn't add testing to the title. But I'll show you a bit about testing too. And the good thing about these smart use cases is that they're, through the years, we've been working with this stuff for 12 years now, and over the years we've seen that there's quite a few standard types of these smart use cases that we see in projects occur quite a lot. And in UML, these are called stereotypes. So I'll show you a bit about these stereotypes, and these stereotypes can actually help you to make the analysis part of your project more easy, because people from the business, the end users, the people you actually model with, they start to recognize these standard types as well, and they start to adhere to these standard types. They will say, hey, I need a manage for customer, or I need an aggregate over these two services, etc., etc. And they start getting used to that, and that helps in modeling, and it also helps in creating your estimates even better. So I'll try to show all of that to you. So, first of all, about the complexity of projects. I was in Brasilia 2 weeks ago, which is the capital of Brazil, to do some talks at a conference. And Brasilia it's an interesting city. It's been built in the 60s out of nothing, out of the blue. They built it there to have a new capital, and they put out a request for proposal for the design of the whole city, which is a big city. I think there's about 500,000 people living there, and then 2.2 million in the satellite cities around it. And out came this RFP, and the guy who won, this is his whole design for the city. It's typed out, it's in an actual typing machine, and there's some drawings in it, a lot of drawings actually, a lot of models actually. And this is the whole design. It's 20 pages long for a whole city. And then we get into software development projects. And I've seen a lot of proposals for software development projects, but it's been a while since I've seen one that only consists of 20 pages. They mostly consist of hundreds and hundreds of pages, and that's only the proposal. And you might ask yourselves, well, why is this stuff that we're doing in this field so complex? Well, it's complex for a lot of reasons. And I'll try to show you some of them. It's because in these projects, there will be many different stakeholders. For instance, if you go for a large organization, I've worked for a large transport organization in the Netherlands over the past few years, there's about 20 different departments in the business that all want to deal with the stuff you're building. And that's hard. And then there's external stakeholders, like if you have to integrate with stuff and software that's outside of your own company, or in the cloud, or wherever it sits, you get to deal with parties that are on the outside of your company as well. These are also stakeholders for your project. And then again, if you go to these projects, these are mostly long-running projects. It's not a project. Service-oriented architectures are mostly into programs that consist of multiple projects that might be running at the same time or after each other. The idea is that such a program may last for 4 to 5 years. And well, that's soon. He stopped already. So there's requirements will change during these 4 or 5 years due to legislation, or due to changing IDs in the business, or maybe because interfaces with other parties change. So a lot of the requirements will actually change on a project. Usually requirements change between 20 to 25% during a project. If you have a project that is spanning multiple years, that will be a lot of requirements. That will cost you a lot of money during the project. It also makes the project hard. And then there's many types of deliverables that you might have. There's deliverables that you do for your design, like use cases, or maybe you're trying to use user stories, or you have domain models, or whatever you're writing down. And there's a lot of different types of software that you're developing in these projects. It's not just a bunch of .NET developers writing some code. In most cases, these organizations have really large IT landscapes, which means they will have everything in the kitchen sink, including SAP implementations, Oracle implementations, PeopleSoft, using Salesforce, using their own built Java backend applications, having some sort of middleware, an enterprise service bus, a lot of different types of portals in a lot of different types of technologies. Could be SharePoint, could be Java, could be plain.NET, could be just about anything. Mobile devices, and they all hook together. And having all these different types of stuff that you need to build will take that there's a lot of different roles in your projects. It's not just the .NET developer. There's an enterprise architect to it. There's a designer, there's an analyst, there's an SAP CRM consultant in your project, for instance, or somebody who writes code to SAP implementations, or Java developers, or .NET developers. So it's complex. And the bad thing about it is, especially when having such a large amount of different types of deliverables, is that it's very hard to estimate these projects. And because they're very hard to estimate, they're of course very hard to plan. And let alone that they're hard to build, hard to test. And what's even harder in most of these projects is try to deploy all the stuff. Because you're not only deploying a single application, you're deploying a whole application landscape. You have to get a new version out, a new release out for everything that's in your landscape, because they all tie together. And that's hard. And that's why people move to service orientation. So this is such an example. I used this example on Monday too. Has anybody been to my talk on Monday? Only a few? Okay, then I could use the same example again. This is the IT landscape for the customer service department of one of my customers. This is just customer services. Every rectangle in this picture is a system. Every line that's in this picture is a dependency on one system on the other system. And to give you an example of the size of this picture, and people who were there on Monday don't guess, this single pink rectangle is called SAP CRM. And at one time, it has an Oracle database underneath, and at one time we tried to check how many tables there were in this database, just to give you an idea of the size of this landscape. Take a guess. 1,000? A lot more. A lot more. 5,000. No, it's more. It's. I'll tell you anyway, but you'll never guess. It's 142,000. Yeah, you know. You're not allowed to guess. 142,000 tables in the database of this single rectangle, which is just one of the rectangles. It's one of the biggest. It's not even the biggest. This one is the biggest. And all these systems are tied together. So every business process that they try to implement or try to re-implement runs through this landscape. And it runs through maybe 8 or 10 of these systems that all have to collaborate in doing parts of the process. And that's hard. That's why people go to service orientation. Why? Well, first of all, it might or it should allow you to get all the services that you have in your landscape and try to reuse them. Which means if there's a service, for instance, to get the subscription for some customer out of SAP CRM, it might be reused in a number of different business processes. And getting that reuse will allow you to do the next project better, and it might be even cheaper because you're reusing stuff. And being able to do that will allow you to have shorter time to market. Implement the new business processes sooner, and get them out into deployment, into production sooner than you would do in such a complex landscape. Another argument for this is that people are trying to rationalize on their application landscape. I'll show you again the picture. This company, for instance, is trying to get rid of a number of the systems in their landscape. I'm not saying it's per se these, but it's just an example. Why? Well, for instance, if you have less systems in your landscape working together, that means that you can deploy faster. That means that you will have a shorter time to market. That means that you will be able to develop more new business processes in the same time. But the only way to do this is to get the services that were delivered by one of these systems. You still need to have them in the landscape in your existing business process. So we have to move them from one system to the other. So you have to identify them and find out in what other system they can be placed. In this case, a lot of the services that were in the landscape will be moved to SAP CRM. But if you move them, that means also the lines change. So if the lines change, you will need something in between to make sure that all these lines will still be in the same place. And people calling on these services will actually end up at the right endpoint. In most cases, that will be handled by something which can be called an enterprise service bus. So that's the idea about being in service-oriented architecture projects. And if you do these projects, they're almost always, no, actually they're always focused on implementing business processes. And these business processes run through the whole landscape, and you try to get rid of a lot of the parts in landscape. But you always have to focus on the business processes. That means if you start looking at the requirements for your projects, these will always come from these business processes that they try to implement. So the business come up with new ideas, new business processes, new platforms that they want to use, be able to get new subscriptions to your mobile phone, or see which trains are running on time, etc., etc. And that all goes through the same landscape. So focus on the business processes. Now I'll give you an example of what we call a smart use case diagram. This is actually one that comes from the same company. And it's a very large smart use case diagram. It's much larger than the average smart use case diagram, but this is because it comes from a service-oriented architecture. And it has a number of interesting parts in here. For instance, you would look at the orange use cases, and they're colored by the standard types that we use there. The orange use cases are all in the portal, in the customer portal, which is actually a Java portal. And there's the ones on the right side, the blue ones, and the light yellow ones, and the brown ones, and the other blue ones, and the gray ones. These are all services that are delivered by individual systems in the landscape. For instance, the one I mentioned about getting, it's this little oval. Each of these ovals in this diagram is a smart use case. And then there's use cases that actually do stuff that you say, well, that would be in the middleware, like stuff workflow, executing processes or part of a process. And the last type that you will see in this case are the green ones. Those actually do transformations between services into other types of messages that they get back, do aggregates, calculations, stuff like that. So this is a complex smart use case diagram. And I'll show you in about, I don't know, in about half an hour, I guess, that actually this one is comprised of 5 different, let's see, 1, 2, 3, 4, 5 different smart use case diagrams. One of them that models the user interface onto, let's say, the middleware, and 4 of them that go from the middleware into all the back-end systems. And this has proven to be a very good modeling technique for doing these kinds of projects. So I'll try to explain to you how it works. I'll skip some of the slides because prefer not to do slides with a lot of text on it, because otherwise you won't have anything to read on your way back to the next session. So I'll just dive into what it does. So what we did over the years is, at first we were doing use cases, and that was back in, let's say, 1996, 1997, sort of. And at one point in time, we realized that the use cases that we were using, they were either too big to implement in a short time, because we were starting to do agile software development at that time. So they could stretch up to 65 pages of text, having a basic scenario of around 12 pages and hundreds of alternative flows and stuff like that. And that is very hard if you want to implement those use cases. And you've probably all seen those use cases. That is the reason, use cases at that level are the reason that use cases, the popularity of use cases declined over the years. And the good thing about it, it's not really necessary, because it is a very good technique. And it is the best known and technique for doing requirements in a lot of projects worldwide. But when we looked at those use cases...
Can I ask a quick question on that?
Sure.
Because I've sort of been wondering about whether this fits lighter solutions. So you started out talking about, well, this is for larger projects, service-oriented, and then you just mentioned, well, you just said it could be used for a lot of projects. So could you explain, I mean, could this be used for like spiral model and some quick development projects that are going to be improved, rather than some of these sounds like they're very intensively architected and analyzed at the beginning. So maybe if you could just give a flavor of what projects.
That's a good question. To be quite honest, I've only been doing agile projects for the last 12 years. So we use it a lot in agile and iterative projects. And the way we do that, but it's actually something I tried to explain in my talk on Monday, because there was a talk about agile and a lot of agile anti-patterns, is that what we do early on in a project is we model it out. The model you see here doesn't have anything else to it than just this picture. So there's all these little ovals, and there's the stick figures on the left and on the right, and there's the names in there, and that's the stuff we do at the start of a project. And you can do that really, really quick. If you're used to this technique, you can actually do that, do a diagram like this in about 2 hours. And that will give you a good overview of what you're actually trying to realize in software. That doesn't mean that you're going to add all the details really early on in the project, because we usually do that during the iterations in the project. So each iteration, we will pick up a number of these use cases and try to elaborate on that, do the analysis, do the design, do the development, testing, and get it accepted. So this technique, and this is a very huge diagram, usually they're a lot smaller, this technique really, really works well in agile software development or in spiral model projects too. So does that answer your question?
Yes, that's very clear. Thank you.
Okay. You're welcome. So I'll show you how we get to these use cases. First of all, I was saying that a lot of the traditional use cases were actually far too big to be actually really good implemented, and they were very, very hard to test. Then I started reading a book by a guy called Alistair Coburn, and the book's called Writing Effective Use Cases, which is a really, really good book. I can recommend it for sure. And in that book, he has a model that says use cases can exist at different levels. And when we start to realize that we could do use cases at another level than, let's say, the traditional level, we came up with the idea of trying to model it out one level deeper. And that's the level that you see here in these pictures. So then we started to realize that you could have an approach that goes from all the way from the scope of your project to your business processes, either hierarchical or chronological, into the use cases, the traditional use cases, and then move on to the smart use cases. And it goes even further, because over the years, but that's not the topic of today, we also found out that there's a very good way of implementing these use cases, for instance, in .NET projects. I did a talk on that at Tech at Europe. The slides for that and the presentation video are still up on Channel 9, I guess. It's called Implementing and Unit Testing Smart Use Cases. So that's actually the sequel to this presentation. And there's also very good ways of testing these smart use cases in a very standardized way too. So that helps a lot in gaining speed in your project. So where's the approach starting? The approach starts at looking at the scope of your project. It's always important to look at the scope of your project. I will show you some pictures of scopes of projects. These are mostly very loosely drawn pictures, mostly drawn by enterprise architects or a business analyst, or even project managers might do that. And the scope of your project in an enterprise project but also in smaller projects that can be the same case, will always be that you try to implement a whole bunch of processes. So what we usually do is come up with the clusters of processes that we try to implement in these projects. And from that level, you can drill down in either a hierarchical, this is a difficult word for me, but you know what it says. So, so I cannot pronounce it. I cannot even pronounce it in Dutch, let alone in English. So it can go either two ways. You can go into the first one on the top, which is, for instance, the idea of authorization is such a model. So authorization will be the top rectangle, and authorization consists of a number of independent processes to implement, like log in, log out, change password, a reset password, whatever, manage roles and users, manage permissions, stuff like that. These are all independent processes, so you can put them out into separate rectangles in any of these diagram types. But the good thing about this is all the diagram types that you will see here on the left can be just about anything. I've seen people model these stuff out in organizational charts in PowerPoint. That works really well, and that's good. And the second thing is, it's chronological processes. Like, I have to book a trip. I have to go through Brazil and then to Atlanta and then go back to Amsterdam. And I have to get a hotel. So it's a process that consists of a number of steps that go together. And from end to end, we'll implement a process. And these are, in most cases, the interesting processes in your project. So what's the next step? Well, the next step is you can do this a number of times, or maybe doing it the first time you're at the right level, but sometimes you need to go one level deeper even. And the level you're trying to reach is something that business process analysts will call elementary business process level. So if you end up with a diagram, any type of diagram, where you would be able to say, each of the rectangles in my diagram is an elementary business process, that is a very good point in time to say, okay, I'm now moving from business analysis, maybe some information analysis, into software development. And that's the point that you could say, okay, here I'm moving from business processes to use cases. So what you could do is this. Each of these rectangles in the process diagrams, so for instance, this rectangle here, and I'll show you an example in a moment, you could say, if a process is at elementary business process level, it has sort of like the same goals as a traditional use case would have. There's a very good rule of thumb for identifying elementary business processes, and it's the Otopop rule. It says one time, one place, one person. If a process is executed by one role at a certain point in time, at a certain location, in most cases that will be an elementary business process. Like for instance, get a subscription or book a ticket. These are all elementary business processes. And this is actually exactly the same level that you would want to have for modeling use cases. So traditional use cases also sit at the same level. And that's the level that Alistair Coburn, that's where these pictograms come on the top, he said, well, that's C level. That's the level where each of the elements will try to implement something that has a particular goal for a particular group of users. And you try to reach that goal, like how many subscriptions can I handle per day? How many tickets can I book per day? That's what your systems do. And this will end you up with the use cases that I call the traditional use cases that can either be really, really big, but they can also be really, really small. For instance, if I look at the authorization on the top of the diagram, logging in is also an elementary business process at sea level. So it becomes a traditional use case. But it's very different from book a trip. And that's the reason we say, okay, you could model it one level deeper. And model it one level deeper will end you up with a number of use case diagrams that actually have a lot of these ovals in them. And each of these ovals helps with implementing the C-level use case. So that's the steps you could take in modeling this stuff out. And to answer the question again about doing this in Agile or short iterative or spiral model projects, this is actually, for the most projects we do, we can do this in 2 weeks. And I'll show you a number of examples. The first example I have, it's actually in Dutch. So it's not about the content of the process, it's about looking at the diagrams that are in the examples. I've got some English examples in a moment too, by the way. So here's the levels again. And this is the interesting level. This is the user goal level or the C level. This is where the traditional use case sits. And this is the level which is called fish level or subfunction level. It's the same thing. that are the other use cases. For instance, if I would buy a book at Amazon, the whole process would be buy a book or place an order, and one of the steps in that process will be deciding what book to buy. So selecting a book or searching for a book or whatever you do, that will be a use case that sits at its sub-function level. By the way, can anybody see I'm used to using this one, and on Monday I was in a really big room and people say we couldn't see the red dot. Can everybody in the back see the red dot? Yes. Okay, cool. Then I can use it here. That's good. So, so we try to identify both the use cases at sea level and the use cases at fish level. Those together become your smart use cases. So here's the difference, for instance, from, this is actually pictures that come from the website. Here's a use case that is called register call. This is a use case that sits at sea level. And you know, register a call in a call center application. That means a customer phones you and says, hey, my washing machine broke down. And they say, okay, who are you anyway? Can we please have your customer reference number or whatever? They try to find you in the system. And if you're not there, they will register you. And after that, they will find out whether it's an existing call already, and if so, add some new information to it, or maybe register a new call. And then add the product to it that was broken down, and add the first action to it, maybe assign the first mechanic to it. So you can write that all down in the use case document doing a traditional use case. But what you could also do is, this is actually the same thing. So it says, here's the same register call use case. This one is the same as that one, except this one has a lot of, let's call it helper use cases. Like search for a customer, and this one should be actually called create customer. If the customer wasn't found, we should be able to create one. Search for an existing call, or maybe register a new call. And then search for the product that was broken, and try to identify the first activity. This is the same thing as you would do if you would write it down. And there's a lot of difference in doing this diagram instead of doing this diagram. Because a lot of the complexity of what was in the process will now be in the diagram and not in the text. And putting things in a diagram makes it much more clear. It's much easier to draw these diagrams in workshops with the users, with the project manager, with the stakeholders. They will understand these pictures, and they will not have you write a lot of text during these workshops. So it's a very good technique for doing that. So an example from the top. This is an ugly picture. It's actually the scope picture of a large program that is being executed in the Netherlands. We're now in the 5th project of the 6. And each of the different colors is a different project within the program. And this is the scope picture. This is where we started off. And then we said, okay, let's start off with the green project. It's called Cross. And this is the actual diagram that models the processes for this project. So here's the project on top, and here are the processes that sit at cloud level, and we've identified all the kite level processes underneath. And I've put a line around this one because I'm going to look at the next level. This particular process is modeled out into one level deeper. So this is a diagram that exists at kite level. It's actually a UML activity diagram, but it could be any other diagram technique that you might want to use for doing chronological processes like BPMN diagram, or maybe a flowchart, or whatever you're used to doing. The important thing about this diagram is that the individual steps in the diagram, they are all at elementary business process level. The ODPAP principle really goes for all of them. That means from here we can go into the use cases. So this one, which in Dutch is called afletteren betalingen. It's very hard to translate that, by the way. It has to do with payments to existing customers, and there has to be letters printed for that. So that's more or less what it does. And if you look at the use case diagram that goes underneath, that actually models out this particular process step, it will look like this. And this is a use case diagram of a regular size. And the interesting thing about this particular use case diagram, it doesn't have a user interface. This is a bunch of services that is implemented in SAP ECC, by the way. So this is a bunch of services that come together in the main service, and that can be called from anywhere else. Actually, it's called from within this particular process. But it can also be called from a number of other processes. So I'll give you an example in English that actually comes from one of my projects that I'm currently running. This is a modeling tool called Enterprise Architect. This is basically the same idea. So here's the different levels. Here's the project. It's called Titan. And Titan exists of a number of groups of processes like investments, accounting, payments, contacts, membership, donations, and a number of other stuff like reporting, document management, authorization. So if I click on one of these, I will go to the next level. This is kite level. And this kite level says, well, within the contacts group, there's actions. I have to do stuff with manage a contact, delete a contact, and manage contact filter. And these are all at kite level, which means I can do a use case diagram from here that would actually look a lot like this. So this is a really big one too.
Then do we, that's my question, this is a smart use case. Do we have to use a specific tool, this tool that you're using here in order to use these? Or is it, let's say we wanted to take this home and actually do it. How do we get started? We buy some tool set, or what does smart mean?
Smart is not, does nothing have nothing to do with any of the tools you're using. The word smart in front of the use case actually comes from an agile approach that is called SMART. And it's an approach where this approach for modeling these use cases actually comes from. Hence, that's why they call them smart use cases. So this is just an example UML tool. I'm a bit reluctant on showing tools because people might think, oh, you have to use this tool, which is not true. There's around, I don't know, 150 to 200 different UML tools in the market you can use. You can also do it in Visual Studio, for instance. Visual Studio will allow you to do use case modeling, but it's a bit limited. So there will probably in the next version there will be better support for modeling use cases in Visual Studio. I would prefer doing it in a UML modeling tool myself. This particular one, which is called Enterprise Architect, it's not a very expensive tool, by the way. The licenses must be around $200 per seat. But I'm not going to advertise for this tool. Most of these tools will have a repository underneath. In this particular case, it will be a SQL Server database, which means that everything that sits in the model sits at one location. Which means if I want to reuse either one of these little ovals in the model, I can just pull it out of the repository and plug it into my model. So that allows you, if you have bigger projects or groups of projects, to build up a whole repository out of these use cases.
Okay. I think I've got it. Let me just check that in. So this is pretty much a standard tool approach. I'm just not familiar with it. The smart UML, and we could get almost any UML tool set, and it'll work with it, right?
Yeah.
Is it okay?
Yeah. So this is the way we use these use case diagrams. The way we model them. That is actually just a technique. And it is supported by any UML tool. Any use case modeling tool will be able to do this, because it's so standard that there's nothing else to it. Okay, so this is one of the use case diagrams. So next step. So the next question would probably be, is if I am at the C-level use case, like the register call use case, how do I get to the next level? And what we did over the years is come up with a number of guidelines that will help you identify these sub-function level or fish level use cases. For instance, if you're doing this model and you're looking at the steps of your user goal level use case, at some point in time you might want to say, hey, here I have to search for a customer. This search customer might be something that you want to reuse in the rest of your project. And reuse is good, of course, especially when you can reuse your requirements even before you've implemented them. So you might say, okay, I'm probably going to reuse this one, so I'm pulling it out. So I'm making a separate use case for this one. And the same goes for what we usually do is say, well, do not allow for multiple user interface screens or web pages or whatever to be in the same use case. Because if you do that, you would need to model out you need to write out all the interaction between the different screens or web pages or forms or whatever you might have within the use case. So if you don't do that and you have one page or one screen per use case, the interaction between the use cases will be, and between the screens, will be in the model instead of in the text. And that saves a lot of work. And it's actually, they'll come out at a very good level of granularity if you do that. The same goes, by the way, if you're building portals and you have web parts in there, or you have tab folders on your larger pages, you would also be able to model them out into separate use cases. And the same goes for, let's say, complex calculations. I've been doing a couple of projects at a pension fund, and we had to calculate something which we call pre-pension. Well, that's probably not something you have here, maybe what you do, but I didn't know how to calculate that, but I knew it was a complex calculation. So I pulled it out into a separate use case. So there's a whole bunch of these reasons for pulling out use cases at sub-function level. And if you do that, you end up with diagrams like these. Usually when we are in projects, especially when we do agile projects, we usually print out all these models and put them on the wall to be able to discuss them with the team. And it's something that you can actually use pretty well to communicate with all the different roles in your project. You can communicate with the end users using this because they will easily understand this. It's just a bunch of ovals. And you will be able to communicate with the developers because they know what these use cases will look like. And you'll be able to communicate with the testers because there's a standardized approach to testing these use cases too. No matter whether they're services or user interface related use cases. So the next step is something that you might want to do during your iterations, or if you're still in a waterfall project, which I wouldn't recommend, by the way. In a waterfall project, you will do this really early on, but if you're in an agile or an iterative project, you will do this during your iterations usually. And that's describing your use case. Use cases, actually, if you look up use case template, you would Google or Bing it, you would find a whole bunch of different templates for describing use cases. There's actually a lot of variations in that. But basically, they will all do the same. They will describe who's the actor, who's executing the use case, who's benefiting from executing the use case, actually. And that's called the actor. That's the stick figure that you see on the left side. And what's the goal for the use case? What do I try to achieve? And then there's the pre and the post conditions. And the preconditions are the conditions that you must meet before the use case can run. They don't always have preconditions, but for instance, if I'm an account manager, I'm trying to visit a customer, and I'm trying to plan that visit, and I'm only allowed to pay visits to people that are in my region. So that might be a precondition to the use case plan visit. And there's post conditions, and these are really important because the post conditions will allow you to test the use case. The post conditions is the stuff that the use case does for you. So for instance, if I have the use case, which is a service that says, get me the subscription for this particular customer, it will get me back an XML message that has all the subscription data for this customer. But it can also be that I entered maybe the wrong ID for a customer, a non-existing ID, which means that the use case will pass back an error message. So these are the different post conditions that a use case might have. And since we're in diagrams where one use case calls on another, when the other one is finished, the calling use case wants to check what post condition has been met, because that's the way his process will continue. So these post conditions become really important when you test it. And then the most work will go into describing the flows in the use case. And there's something called the basic flow. It can also be called the happy day scenario or the happy flow, or there's different names for that. It's a bit depending on whether which literature you read about it. So the basic flow, actually what it does is it's the number of steps a use case follows that you need to go through to the use case to end up at a positive post condition. So to make the use case successful. And for many of these steps in your use case description, you can deviate. There can be things that might go wrong, and you need to go into another direction. Those are described in something that we call alternative flows. Usually these are numbered, as I'll show you in an example. This is actually an example where here's the actor and the goal. The actor here is somebody called the fleet manager. This is actually for a car lease company. And there's the post conditions and the preconditions here. And they sort of define the contract. It's a bit of design by contract writing use cases. So in this case, this is a pretty straightforward use case. It says, well, a driver is, what does it actually say? A driver is saved into the system, or no driver is saved into the system. That's the negative post condition that you can go through if you go to an alternative flow that ends up in a negative end result. And here's the basic flow. Typically, you will see a number of steps, and this one is this is not a very good example because there's a lot of stuff in here that I wouldn't write. I wouldn't recommend, for instance, to have the first step saying, the manager selects to create a new driver. Actually, this would be like starting the use case in the use case itself. So starting the use case does not belong to the use case, in my opinion. And there's a couple of alternative flows, but they didn't fit the page, so I don't have them in the example. And the alternative flows will actually branch off of one of these steps that you might have here. So they might branch off of step 3. Like, what does it say? The system sets the status of the driver to the default status active. What if he doesn't? What if he puts it in another status? What will happen? That could be an alternative flow. And alternative flows might end up back at the same step. They might enter back into the basic scenario at another step, or they might go into a negative end state. So there's a lot of variation in there. So what you try to do is, if you write down the use cases, if you describe your use cases, is keep this text as limited as possible. And you can keep that limited if the use cases are pretty small. So if you model smart use cases with the sub-function level use cases to it, the descriptions that you will have for each of these individual use cases will, in most cases, not be longer than 2 to 3 pages. And use cases that are 2 to 3 pages are much better to test. They're easier to estimate, and they're much easier to test than having these big use cases. So there's the difference. So what do you do if you test this stuff? In the Agile process, SMART, there's actually, where the SMART use case is actually the main unit of work, there's actually a cycle that all of these use cases go through. For instance, if we start up a new use case, we try to identify what to do about it. We mostly do that during our stand-up meetings. And then we decide whether to have a design session. And mostly in our Agile projects, these are right after the stand-up meeting. So let's say from 10 to 11, where we decide on everything that we need to know about this use case. And the good thing about being in an Agile project is that if you go along the project, you will learn more and more about the project, which allows you to define the use case much faster and faster than you would do if you would have to do that in the beginning of your project, being in a waterfall project. So the next step is that we try to write down all the test scenarios that come from the basic flow and the alternative flows. And with the test scenarios come the test cases, and I'll show you some examples for that too. And then we start coding. So we first write down the test design before we start coding. And there's a good reason for doing that, is that it implementing bugs and getting rid of them afterwards, you prevent the bugs. So if you do the test design with the tester and the developer together, maybe even with an end user or the analyst or the enterprise architect to it, if you do the test design like that, you will make sure that both the tester and the developer have the same idea about what this use case actually is. So that means, because testers usually have a very different mindset to looking at a specification. A developer will say, okay, I'm going to implement this, this, and this, and then I'll be done. And then a tester would come up and say, what if something goes wrong in step 4? If you forget to add that one, or you didn't press that button, but you pressed that button, then where would you go? And if you have the end user with you, they would say, okay, well, this is an exceptional case, and we need to add another use case for that, or maybe another step, or et cetera, et cetera. So the design improves by doing it together with a tester. And the tester writes down all the test scenarios while the developers are building this stuff. Then you can test it. So this is basically the life cycle. And if the test fails, of course, you go into rework, and you might go back to design, et cetera. And in the end, you try to get the stuff accepted. That's the way it works. Just a picture from an actual project. This is a typical situation in such a project. Here are the two developers. They're actually pair programming right now. And this is the tester in that project, and this is the end user. They have been sitting together just before I took this picture, deciding on how this use case should be implemented. And they actually draw a UML activity diagram for defining all the scenarios, and that's the diagram that he has in front of him. And while they're actually defining the test cases and the tests of the actual test data for doing the test for this use case, they're actually implementing it at the same point in time. So this gives you an idea of how this actually will work in practice. So out comes these test scenarios. Like there's a technique that you can do for that. It's called a process cycle test, and it says, well, define a diagram, whether that's an activity diagram or a flowchart. It's a chronological process diagram again that goes through all the steps of the use case. So each of these rectangles here is one of the steps in the use case. In one of these use cases, I don't know by heart which one it is. It's one of them in this diagram. And what you'll see here is that the happy day scenario, we usually draw that from the top to the bottom. So anybody in the project knows that if I go from top to bottom, I will be at the positive post condition. And there's the exception scenarios. For instance, I go through here and here, and here's a decision that will get me into an exception scenario, and here the use case ends here. And there can also be recovery scenarios. For instance, I'm going here, and I cannot go through this decision, so I have to go back here, and maybe loop through here a number of times, and then might be ending up here. I could also end up here, of course. But so that will identify all the scenarios that you can execute by running this use case. And that's important for the testers, because what the testers do is they can identify partial paths in this diagram and connect the partial paths. For instance, they will have to test every decision node in the diagram. So they will have to test whether a test case passes through here and a test case passes through here. So they will write down any combination of these two, like 1, 2, and there's 2, 3, and there should be one here, down 2. That's probably, I don't know, there's probably a 5 here, so there's 2, 5. And from 3 I can go back to 5, and I can go from 5 to 4. That's strange numbering, but it's not my document. It's an example. So they get all these partial paths, and combining these partial paths, they will come up with the test scenarios that they will define test cases for. So here's a couple of these. Here are all the pairs, the partial paths, and here are the combinations of the partial paths that are possible. This is just plain math. So they come up with all the scenarios, and for each of the scenarios, they will do something like this. This is why testers are always underpaid, and why testing is always underestimated, because writing down the test cases for your test scenarios is a lot of work. It's much more work than you would accept. I had a discussion earlier this week with somebody who said, what's the correct ratio between developers and testers? And he said, well, we have about 4 to 5 developers and 1 tester. And I would say, well, I would much rather have 1 tester per 2 developers, or maybe even 1 on 1, because it's an enormous amount of work if you want to do testing right. So especially in a complex project with a lot of services out there, testing becomes really, really important. So I always love to have testers in my projects. So that's the testing part. So then we start to identify that there's a lot of standard types in these use cases. And we started out by creating websites using these use cases. So we had management screens, like I want to have a screen to manage my customer. Or it's a customer with their orders on it, and if I click on an order, I want to go to the order with the order lines in it. Well, order with order lines would be something which we usually call a master detail. So there's a lot of these standard types that you want to apply to your modeling. For instance, in this diagram on the right, there's something that says search site. A search is something you would recognize immediately. It's something with a lot of search criteria, parameters that you can fill in, press submit, and out comes a list of sites, or a list of customers, or a list of products. So they're always more or less the same. So these are really standardized ways of describing your requirements. So if a customer during an analysis session says, okay, we need to find a customer based on a number of criteria. I don't know the criteria yet, but I know that's sort of like the case. Well, that's search customer. Bang, you've got it, you nailed it. There's nothing more to it. And these standard types of use cases, in most cases, we do a lot of projects that go offshore. And going offshore means that you will have to be very elaborate on your requirements that you send off to wherever you send them off to. And if you do these much more standardized, like we could do with these use cases, you would have to specify much less to get the work done correctly. And that really works. So we added a lot of these stereotypes. We started off with doing these for projects that have a lot of user interface. But over the years, we come up with a number of other of these standard types that we also use in service-oriented architecture projects or in BI projects, or well, Java and .NET projects are of course more or less the same. And the funny thing is, it gets into your vocabulary. So you start using things like, hey, this is a master detail for product and order, or it's an aggregate where we aggregate customers and orders and then pass back a message, or we need to import a list of products. So that these become your standard types, and that's very easy to do in analysis. So we've put out a list of these standard types on the website. There's about, I don't know, 30 to 35 of them already. And since this thing is a wiki, if you start doing this and you start discovering new stereotypes, don't hesitate to add them to the list. But most of the stuff is already there. So I think this year we came up only with one new type because we have so many types already. So that's the standard types. And the good thing about it is it also helps you estimate it more easily. And I'll do that on the end of the talk, talk a bit about estimation. So you can see that all the standard types, we use these different colors for them as well. And using a UML modeling tool, you can define your own stereotypes, your own standard types in a UML modeling tool, and you can add these colors to it. So usually the user interface related use cases are all in orange or in yellow, so we can easily recognize them. And services, mostly the workflow oriented, will be in purple. That's the way we usually model them. But you can use other colors, of course. It's your own choice. So the next step is what if I'm in these large service-oriented projects? Can I use the same technique to go from front to all the way back to my legacy systems? And it took us a while to figure that out. We were spending some time between 2003 and 2005 finding out how to do this. And then in 2008, a number of projects came up that actually wanted to use this diagram technique for doing those projects. So I coached them myself, and well, the results were very, very good. So I'll show you how we do this. So basically, any service-oriented architecture looks a bit like this. There's either stuff that's consuming services, and there's stuff that's provisioning services. So there's services in the back end, like the one that I said, well, get the subscription for a certain customer. And there's applications on the front end that actually need these services. And there's usually something in between. It's usually an enterprise service bus, but it doesn't have to be. But usually what you will see is that there's stuff doing workflow and transforming other services into different messages. Like I'm getting my customers from this system, I'm getting the orders for customers from another system. Let's put them together, aggregate that, and get that back to the user interface. So that's stuff you can also do. So what you see here, there's a clear separation between to the service bus or to the middleware or whatever you have in the middle, and from the middleware into the legacy systems. Or they might not be legacy systems, they can be very accurate systems, very new systems, but there's systems that provide services. So there's two kinds of diagrams that we do here. First of all, there's the diagrams that come from the end user on the left side and go all the way up to, let's say, the middleware. And what you will see is if I put up a diagram like this, this is such a diagram. Again, it's in Dutch, I'm sorry for that. I didn't expect that a lot of the projects I do, usually we do them in English. My company is an international company, so we do almost everything in English. But if you go to local customers, they want to have the local language. So that's why a lot of these examples are in Dutch. So this particular diagram, it has a lot of user interface in here. So this is a view and a master detail and a search and another search and a manage, which is just managing one entity. And there's a different one which is called confirm and has some additional functionality. And here's the red ones. We have modeled them in red especially because this is the hard part. This is actually a diagram that goes into a legacy a back-end SAP system again. There's a lot of SAP out there in the world. So each of these red use cases actually go into that SAP system. But everything that we model in this SAP system, the services and the things we need to call, the BAPIs that we need to call to get this stuff together, is in other diagrams. Those are the diagrams that go from the middleware into the back end. So this is the front end stuff. What we usually do, by the way, is that we add more of these stick figures to the right of the diagram, representing the systems that these services are called in. So for instance, this system is called Treza, so there would be actually 3 stick figures because it's the same system. But for aesthetical reasons, I removed the stick figure from this diagram. So I'll give you another example. Okay, so this is your user interface, and this goes all the way to the services that you need. So the second part is coming from, let's say, the middleware, the workflow, or the enterprise service bus, you will need to go into the back-end systems. And that's the second type of diagram. And this diagram, this little red use case, is more or less the same use case as you saw in the previous diagram. But this case, it's the starting one. So in most cases, the actor here will be the client-side application. Like this diagram here, going back one thing, this is my client system, so this is my end-user facing system, and one of the processes in that. And in this particular diagram, that user interface, that front-end system, is actually the actor for the middleware stuff. So this goes way back into, in this case, it's an SAP system again. Again, there's a lot of SAP out there. So this is the service again, and this is all the end line, the back-end system services. So that's the way to model that too. So here's a more complex one. This is actually the same idea, only it goes out to different systems and calls on different services from those systems and aggregate them together and execute parts of the process. So here again is the service that the user interface, or the portal in this case for the company requires. So these are the 2 portals that actually require this service. And the service goes out into, I think I'll put them all on the slide now. That's much easier. So the purple ones are actually doing part of the workflow for this particular process. So this one calls out on a process, and the process is divided into a number of different sub-processes. And each of these sub-processes, there's some transformations in there, and there's some back-end services. This one comes from a PeopleSoft implementation, for instance. And this one is, again, an SAP system. And this one here is an outside world actor. So it's a system that doesn't live within in the company that I did this project at. So we call on, we actually call out to the cloud here. And you can also model that by putting such a stick figure which represents the system in the outside world in your diagram. Knowing that if you do this, this will add additional complexity to your system, because going out to other parties requires, again, authorizing and all that kind of stuff, which makes it really, really hard to implement. So this is, again, a service providing use case diagram. And the next step would be adding it all together. So what you do is you start assembling your business processes. So here's an example. This is coming from a large call center application for an energy company. And this is actually the front end. It's written in .NET. And this front end, it was actually, it didn't have a back end. So it's an application that this energy company bought, and it needed to be integrated with their back-end systems, which again are SAP systems. So this particular red use case, again, is linking the user interface here to some service in SAP CRM in this particular case. And this service in SAP CRM calls on other services, and it also calls on a service in another SAP system. So here's the whole integration. Here's the first diagram, and here's actually the second diagram. So you put it together. And that can lead up to diagrams like this one. So this one, again, is my user interface. This is my portal. And there's 4 different of these use case diagrams that provide services here. And the good thing about, the interesting thing about this, this particular process, we implemented this in an Agile project. And we implemented a number of these processes in this Agile project. We originally had 8 iterations of 2 weeks. So after a few iterations, after 5 to 6 iterations, we know what speed we were traveling at. Since we estimate this stuff in smart use case points, which will be the next and the last subject for this talk, since we also know how many hours we took to build all these use cases, we came up with the number of hours per smart use case point. And we also came up with the number of smart use case points per iteration. So after 6 iterations, the product owner in this project, he came up to us and he said, you know what, I actually would like very much to add a new business process to the scope of the project. Usually when you're 3/4 in a project, you don't do that. But since this is an Agile project, we said, okay, let's try to identify how much work this will cost us. So we modeled out a new business process, and it appeared to be that for this particular process, a renew subscription it was, we could reuse a whole lot of these smart use cases that we already had implemented in the original business processes that were in scope of the project. So we identified the missing use cases, which were some services in the back end and some piece of workflow and one screen in particular. So there were only 5 new use cases to the new business process. The rest we already had. They were already in our repository. They were already implemented and tested. So we estimated these 5 new use cases, and there were 20 points. So we said to the product owner, we can actually implement your new business process, but you have to give us an additional iteration. And he said, okay, that's fine. So he knew what it cost because he knew how many hours it took in an iteration. So he said, okay, if there's this amount of money, do that. So we did that. So we got an additional iteration, and we implemented the additional 5 use cases, and it worked fine. Actually, the project was a big success. So that gives you an idea about the amount of reuse that you can get in a service-oriented architecture if you model them out at the correct level. And this is a fine technique for doing that. So here's a good side example. This is actually a UML sequence diagram, which you probably all have seen at some point in time. This is actually a sequence diagram that depicts the same model as this one. What it only does, it models the exchange of services and exchange of messages between the services. So it starts off with this one, which is actually the same one as this one. Or this is a different process. It's a similar process. And it starts off here, and it calls on the other use cases that are on the front end, and it calls on some use cases that sit in the workflow engine. And this one in particular is stretched out further. So this is actually, this will be an elaboration on the front-end use case diagram, so the service consuming use case diagram, and this one is one of the service provision use case diagrams. And what you will see, if you would have gone below, but the picture doesn't go any further, it would actually declare the actual messages that are exchanged between these use cases that are either triggered from, in this case, SAP middleware to SAP backends, and the names of the services and the signatures that come back from that. So it's an elaboration on the messages that are exchanged if you implement a smart use case diagram. So then again, when we did these projects, we said, well, we should have had additional stereotypes for doing service-oriented projects. So we looked at the diagrams that we had over 5 or 6 of these consecutive projects, and we identified a number of these, let's say, server-side stereotypes for smart use cases. And again, there's a list that's also on the website. This is not a complete list, but the complete list is much too long to handle them all individually. So there's something like validate or aggregate different services, put them together, give back an answer, integrate stuff, or maybe calculate stuff, or dispatch stuff in a fire and forget manner. So there's all standard types of use cases you can model too. And the good thing about this is, what I said earlier, is that if you do this, you will be able to create really accurate estimates for your projects. Especially when you've already done such a project, that will actually help because you will have metrics for it. Gathering metrics is, of course, really important. So one thing about estimation. I showed this one on Monday too. So this is an interesting picture. It's the Chicago skyline. And I always use this to try to identify what the best way will be to estimate stuff. There's a lot of projects and a lot of people out there that estimate either in hours or in money. Estimating in hours is a hard thing to do because whoever does the estimation, it's his hours or her hours. If somebody else will do the task, they might not take the same amount of hours for doing that. So the basic idea of estimation is not to estimate at an absolute measure like money or time, but estimate at a point scale. And the Chicago skyline gives a very clear example for doing that. Because suppose I would want to know what the total height is of the buildings in the Chicago skyline. Except the buildings in this picture, of course, because there's a lot more, of course. So you could start out by saying, okay, this long black building, you probably all know how big this is. Well, on Monday there were people saying, oh, it's 110 floors. So I believe that. But in Europe, nobody knows. I do most of my presentations in Europe, and well, I was in Brazil 2 weeks ago, but they didn't know either. In Europe, nobody knows how big this building is. So you could easily ask in a group, how big is this building? And I've had the strangest answers to that. There was people saying it's 100 meters, which is about 300 feet. And there was also somebody saying 2 kilometers. I think there are no buildings yet of 2 kilometers high, but so it's very hard to find out. So suppose this is a bunch of requirements in your project, or it's a bunch of use cases for that matter. It's very hard to find out exactly how long it will take or how big the building will be, which is in the same scale, of course. So it's much better to do it at a relative scale. So if I would say that, suppose this black building, let's call it a 5. I'm creating a scale from 1 to 5. You can create any arbitrary scale, of course. We've created one for the smart use cases anyway, but suppose I got a scale from 1 to 5, and I would call this building 5. How high would this building be? 4. That might be a good answer. And what about this one? Yeah, and this one? Sort of 2. We only use whole numbers, so this is probably a 2. So this will be a 1. So using this relative scale will allow you to estimate the total height of this picture within a minute, literally within the minute. And you might think, how rough is this? Is this really accurate? Well, I can tell you, it will be pretty accurate because there's an interesting thing which is called the law of large numbers. And one of the consequences of that law is, if you estimate a whole bunch of stuff, and you estimate it on a scale, at some point in time you will overestimate one of these items. But since there's a lot of these items, there will probably also be one that you underestimated it. And that will sort of level out. So if you have enough items to estimate, it will level out, and it will actually be a pretty accurate number. So in use cases, if we have use cases in our project, my current project has over 300 use cases. So if you estimate all these use cases, it doesn't really matter whether you say, you don't have to debate very long whether this one is a 4 or a 5. It actually doesn't really matter. If it's a 4 or a 5, it's probably good. Because you will have the same discussion on the other side on one other smart use case that you might say, oh, this is a 2 or a 3. It doesn't really matter. Overall, the big picture will give you an accurate number. And this accurate number will actually give you an estimate on the size of your project. Just like this would do if, suppose this is 200 points in total. That doesn't say anything, because the next step would be finding out how big one of these points is, or in implementing use cases or requirements, how long it will take you to implement one point. And that's something that you need to experience during your project. So we've done a lot of these agile projects using these smart use cases, and in agile project, it's very easy to measure. So for instance, the number I mentioned, 35.2 points per iteration, that's from an actual project. My current project runs at, I don't know by heart, I think it's 24.2 points per iteration. And we run at a speed of 7.9 hours per point. And those are really accurate numbers, and that will help you do the estimate better. So again, if you don't have those numbers, you will need to take a sample of a number of use cases or a number of stories or whatever you're implementing to figure them out, how long it would take the team to implement that. So we do that usually. So here's the scale. This is the actual scale that we're using for these smart use cases. We originally started out with a scale from 1 to 5. And we said, okay, 1 to 5 is good. But I've seen different ranges for different kinds of stuff anyway. So there's also people using Fibonacci numbers, and there's people that do 1, 2, 4, 8, 16 or whatever, or 1, 2, 3, 4, 5, 8, 13, 20, and 100. I've seen that too. So there's different ranges. But this is the range we've been using for, I don't know, for about 10 years now. And that means if we use the range for these smart use cases over this past 10 years, and use cases, no matter what technology you're using, it's a requirements technique. Which means that independent of the technology you're using, you can estimate the actual complexity. The velocity that you get in a project will be different. For instance, the SOA project at a large transportation company, well, they did 35.2 points per iteration. We're doing 24.2. We do 7.9 hours per point. They do 15.2. So there's difference in that because the technology differs. But that's a difference in speed, not in complexity. So it makes up a good metric for comparing projects one to another. So this one has 1,400 points. Oh, this one has 1,600 points. So they might be comparable. They might be on the same size. And that's very good. So this is the scale, and it goes up from really simple ones like I need to select one of the 52, are there 52 states in the US? I always forget that. 50? 50? Okay. I should count the stars, I guess, on the flag. But so if I have to select one out of 50, well, that's an easy one. I could build that easily. Or in the Netherlands, it will be much easier. We have 12 or 13, I don't even know it for the Netherlands. So there's 12 or 13 provinces in the Netherlands. So that's just selecting from a list. That's about the easiest thing you can build. You just select one, that's that. So that will be a 1. Like an average maintenance screen, like a maintenance screen for my customer, we usually estimate it at a 3. But it's not a fixed scale. So for instance, what we usually do, if we do this during modeling sessions, is that we say, this is the use case to manage the customer. So it usually comes with a 3. What do you think, dear customer, dear end user or stakeholder, product owner, analyst, or domain expert, whatever you have? What do you think? Is this more complex than the average maintenance screen? And I say, well, yeah, we're going to add some stuff here and some stuff there, and that needs to be dropped down there and whatever. Okay, then we'll put in a 4 for this one. So that's the way you do these estimates. And that's really easy. And we usually do that with the whole team. Like sit together with all the different roles, and you come up with this one number. In this particular project, by the way, we started off and they all gave a different number. And they said, well, for testing, I need a 4. And the developer said, well, to develop this, I need 3 points. And then I said, no, it's one number for the whole use case. It's not everybody has his own number. No, it's a team number. It's a team figure. And the good thing is, if you estimate in teams, that will mean that you will get commitment from the team doing that. But it gets even better, because what we also do is, when we model use cases, this is a picture coming from an actual use case modeling session. We usually do that with a UML modeling tool, put it on the projector, and with the whole team. And here's the project manager. She doesn't agree, I think. We probably estimated it higher than she said. And during the modeling session, we already estimate. So if I do that, I'll show you. I'll show you in the UM modeling tool that I had open earlier. For instance, this diagram. It has each of these use cases has a number in here, and that's the actual estimate that we do during the modeling. So once we put a use case on the model, we immediately estimate it. And you can do that too. By the way, it's pretty easy doing that. So if you do that, and the good thing is, UML models, you can export UML models to just about anything. And what we usually do is, I hope he doesn't fall off the stage, but if you model this out, and you export it, for instance, to an Excel spreadsheet, which is this one, you will see that you will get an immediate estimate for your project. And you can do that right at your modeling session, which makes it really, really powerful. So if you're modeling with your customers, and they say, well, how big is the project up till now? If we had, I don't know, 3 out of 4 of these sessions, and you say, oh, well, just going to generate the spreadsheet for you, and here's the estimate. So I don't know what this says on top. So there must be a total. Oh, here. This one has a total out of 1,160 smart use case points. And there's how many? 270 smart use cases. And what you also will see here is that the levels that I started with earlier on in the presentation, like the cloud level and the kite level, they're still there. So this is stuff that's coming from the accounting processes. And these are all the processes in there, like balance check or close month or create transaction export batch. And they have a priority, and they have the estimate. So this runs all the way from let's say, getting an idea about an application, running it into scope, and going from your business process into your use cases, smart use cases, and the way to test this stuff. And the part I skipped is about how to implement this stuff, because there's also techniques for doing that, and how to test it and estimate it accurately too. So this is a technique that goes from front to back in all of your projects. So to add up with the last 2 slides, where am I? Here. So this is the same example of another diagram that we estimated on the fly. So, to round up, I hope you got a basic or a good understanding about what these techniques comprise of and what you do and how this approach works. And it's an approach that you can easily use in a lot of different types of projects. Let's say you can do it in web projects, you can do it in agile projects, you can do it in Java projects if you want to do Java projects. You can do it in SOA projects, and we can even do it in BI projects if you like. The technique itself is not that difficult. It's pretty easy to learn. There's some good trainings for that too, by the way. And it's a very good way of communicating with all the different roles in your project. And that's every role, because it's such an easy diagram to interpret, and it's an easy diagram to model too. So, and it gives you a very good unit of work. It gives you a unit of testing, again, especially in Agile project, a unit of estimate, and even a unit for code generation. Because in the end, if you've modeled out these standard types of use cases, there's no reason why you shouldn't be able to generate code from that. To give you a clue about that, I'm not discussing that, but there's a very good white paper on the Capgemini website that is called Pragmatic Model-Driven Development Using Smart Use Cases. I would recommend, if you like model-driven development, to read that, because it will show that from these smart use cases, if you have them standardized already, and you have your domain model also modeled, and you can combine these two, you can generate a whole lot of code from it. Web pages for master details, they're not that hard to generate if you got the model set up right. So it's also a very good basis for doing model-driven development. So that's about all the recommendation I can give you. I'll be here for the rest of the day. So if you have any additional questions, feel free to come up to me. Here's the website that most of this stuff is on. This website also has a number of free downloads, one of them being the code generator that we use to generate from UML models. And there's also some UML profiles that allow you to model the use cases in color and be able to estimate them using the UML modeling tools. So that's about it. Thank you for being here. If you have any additional questions, here's my email address, my Twitter account, the websites that you can find more information on. Thank you for having me here, and I hope you have a good day with the rest of the show.